In today's session, I get to illustrate Dalton's law of partial pressures coming up. In 1801, a scientist called John Dalton observed that when you put two or more gases in a container, each gas contributes to the total pressure of the entire gas. If you look at that illustration, we are having this box, and in here there's gas A and gas B. Of course, when these two gases are inside this container, they are mixed up, and definitely as the molecules are always moving around in that gas, they inflict pressure on these walls. Now let's assume that we remove gas B and we leave gas A alone, or we remove gas A and gas B remains there alone. If we remove gas B and A remains alone, it means A will be still in the same container with the same volume, but now it will only be gas A inflicting pressure on the walls of this container. Likewise, if we leave gas B alone in the container and we remove gas A, it will only be gas B that will be remaining to impose pressure on the walls of this container. Now, this amount of pressure that A would exert if it is left alone, or the amount of pressure that B would exert if it is left alone, is what we are calling partial pressure. So by definition, partial pressure is the pressure that would be exerted by a gas if it fills the container alone. Or I can say partial pressure is the pressure that a gas would exert if it fills alone a container which was previously occupied by a mixture of gases. Now that we know what partial pressure means, we can now go ahead and start talking about Dalton's law of partial pressures. Now, Dalton's law of partial pressure simply states that if two or more gases are put together in a container, and that these gases, when in that container, are not chemically reacting together, then the total pressure of the mixture of those gases is equal to the sum of the partial pressures of the components in those gases. Right here is our gas, and in this gas, this is a mixture of let's say this is a gas, it's having a mixture of gas A and gas B, and these gases, as they are interacting, they are not chemically reacting with each other. Now, the total amount of pressure that is imposed on the walls of this cylinder as a result of this gas, this mixture of gases, is going to be equal to the sum of the partial pressures of those gases. And by partial pressures, like we had earlier illustrated, they are the gases. Gas A would exert if it was alone in that container. Gas B, the amount of pressure it would exert if it was alone in this container. Or if you're having other gases, gas C, gas D, and whatever, the kind of pressure, they are individual partial pressures. When you add all those partial pressures, they give you the total amount of pressure that would be exerted on the walls of that container. And of course, Dalton's law of partial pressures is illustrated like this mathematically, that the total pressure, which you've denoted as P, is going to be the partial pressure of gas A plus the partial pressure of gas B. Of course, here I am using it in such a way that there are only two gases, but they could be more. They could be 5 gases, and the formula will still be the same, that the total pressure in that container is going to be equal to the individual partial pressures of all the gases that are in that mixture. And that is Dalton's law of partial pressures for you. So if I may conclude, Dalton's law of partial pressures states that the total pressure of a mixture of gases which do not react chemically is equal to the sum of the partial pressures of the components of that mixture. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia, helping you manifest excellence.